Welcome everybody for another Untitled user group presentation. This one presentation is going to be presented by Jeff Precise from Wintellect. He's going to take us through our tour of HTML5. Wintellect has been doing a series of presentations for LIDNUG over the last couple of months. And today we have a record registration attendance of 1,408 registered to attend. Before we get on, I'm just going to do a bit of housekeeping. I want to thank our sponsors, Orgsweb and Telerik, for their continuous support, and for Syncfusion for their huge contributions to the Wintellect and LIDNUG series. Also, just want to make everybody aware that this event is being recorded and will be uploaded to our YouTube channel. Upcoming events for October and November have John Robbins from Wintellect doing that performance tuning on October 11. Then we have Mitch Harper doing a practical patterns with JavaScript, MVC4 and HTML5 on November 8. And we have John Palmer back again doing single page apps, and that's on November 15. Keep up with all our events. Go to lidnugevents.eventbrite.com and you will see all our featured events for the next couple of months. Also, if you've registered here and you're attending, you are eligible to win a Wintellect virtual training session valued at $499 US. We will announce the winner at the end of today's presentation. Also, the Syncfusion Tech Portal. Check out the free ebooks. There's a Syncly series and white papers, plus also the Metro Studio 2 application for Windows 8 application style icons creation, and that's a free application from Syncfusion. LIDNUG consists of, for today's team, there's Brian H. Madsen and Peter Shaw. We're emceeing this as it is recording, and we have Inbar, Bethany, and Dan doing Q&A. If you have any issues, look out for the LIDNUG marked members in the attendee list, and feel free to ping us at any time. Our web, link.com, groups on LinkedIn. Go there and search for LIDNUG or LinkedIn user group, and you will find our massive discussion board. Our calendar for upcoming events is bit.ly/LIDNUG_RSS. So catch us on our social media via Twitter/LIDNUG and Facebook /LIDNUG as well. Email us at info@lidnug.org if you have any questions or comments. And of course, our events, LIDNUGevents.eventbrite.com. And I'm going to hand over to Jeff. Jeff Precise, thank you for coming back to us and presenting again.
My pleasure, Brian. Thanks for the kickoff. Thanks for staying up very late at night where you are.
You're welcome. My pleasure.
Well, let me add to Brian's welcome and just welcome everyone that is sitting in today. I'm Jeff Precise, and obviously I'm going to be your presenter here for the next hour and 20 minutes or so. And the presentation I'm going to deliver is entitled Take a Drive with HTML5. There's obviously a lot of interest in HTML5 today, and I want to spend the time that we have together giving you an overview of it with drill downs into selected areas. More than anything else, what I'd like is for you to go away, if you've never looked at HTML5 before, with a pretty good picture in your mind of what's there and what's available, what it can do and what it cannot do, and also how to leverage the features that we're going to look at. In fact, I'll be using quite a few PowerPoint slides today. I'll also be showing lots of code. I'll be sharing my desktop to do that. And one thing I'd like to call your attention to is that you can download handouts from the presentation here. there's a handout button in the upper right corner of the live meeting window. First, there's a copy of the slides that I'll be presenting, and secondly, there's a zip file. It's 15 or 16 megs or so, but it contains the Visual Studio solution with all the demos and samples that I'll be using. So yes, you can download those at your convenience, take a copy home with you, have something to look at after the class is over. So let me say just a word or two about who I am and who we are. We are Wintellect. Wintellect is a company that I co-founded along with some close friends more than a decade ago. If you haven't heard of us, we're a training and consulting company that works with companies that work in the Microsoft stack, whether it's Azure, Windows 8, HTML5, or what have you. We offer consulting and training in those areas. I want to say more about that, but obviously you can visit our website if you'd like to learn more. We do have some additional webinars coming up here in the future, as well as virtual courses that we do through live meeting. There's a link here that you can use to get to our website and learn more about it. Brian mentioned that at the end of the presentation, we'll be giving away one free seat to an upcoming Wintellect virtual course. We do have a 2-day in-depth HTML5 course coming up in the second half of October. If you're the lucky winner of that free seat, you're welcome to use that for the HTML5 course if you'd like. Also, DevScovery is a conference that we put on once or twice a year. This year it's in Houston, Texas. First week of October. There we bring together some of our favorite people, Jeffrey Richter, John Robbins, and a whole bunch of other folks, and ask them to present in-depth, very detailed content on topics that are pertinent to developers. This year HTML5 will have a large presence at the conference, so will Azure, so will Windows 8, so will a lot of other things, and obviously we would love to see you at the conference. There are still a few seats available, I believe, and you can visit the link shown here or www.devscovery.com if you'd like to learn more. One final thing before we get into the real content is, again, we'll be giving away a free seat in a virtual course at the end of this session. And Brian had already mentioned some stuff that's available from Syncfusion, so do go check that out. Lots of good information there. And with that, I would suggest that we get started talking about HTML5. So let's first make sure that we're all starting on the same page here. Exactly what is HTML5? Well, it's not going to surprise anyone to learn that it is the successor to HTML 4.01. Big duh there. Now, what's significant about HTML5 is that it does expand HTML so much. I mean, when you think about it, HTML4 was a markup language. And yes, you could use JavaScript to make pages written in HTML4 more interactive, more responsive. But HTML itself was really just a markup language. It didn't offer features and APIs, so to speak. The reason HTML5 is generating so much buzz these days is it's much, much more than just a markup language. HTML5 is a markup language plus a whole bunch of new features, new APIs that developers can access through JavaScript to build very rich, very interactive, and very responsive web applications without requiring browser plugins. When you write code that targets an HTML5 browser, assuming that browser does support the features that you're targeting, the user can just run the app and doesn't have to download and install anything else separately. The HTML5 feature landscape is quite large. We're going to look at it in just a moment. But it does include a whole lot of APIs, some of which you've probably heard of, some of which you have not. The Canvas API, for example, gets talked about a lot. For the first time ever in an HTML5 browser, we have a way to draw into that browser window, to draw pixels, to draw lines, to do whatever, without requiring any kind of plugins, without requiring SVG support or anything like that. Web storage, another very important topic, one we're going to talk about today, gives you a way to store data on the client side safely and securely, at least without having to open up a security hole and access the user's file system directly. It's really powerful because in the past, whereas we might have stored data in cookies on behalf of individual users, now we have the option of storing it in web storage, where there's several benefits. For one thing, the data you store there doesn't go up and down the wire. and increase the volume of traffic as cookies do. In addition, although there are limits or quotas on the amount of data you can write into web storage, it's much, much larger than the amount, the limit typically placed on cookies. So those are just two of dozens and dozens of different features. We'll go into those in more detail, but what I want you to know right now is that HTML5 is a platform. It's almost like an operating system in a browser in that it provides features and APIs, which you access through JavaScript, to help you build very rich web applications. And again, to do that without browser plugins. Now, it's kind of interesting. If you ask someone what the features of HTML5 are, if you ask them to list those features for you, if you ask 10 different people, you'll probably get 10 different answers because, believe it or not, it's not an easy question to answer. There is no one big specification out there that defines everything that HTML5 is. Instead, it is dozens of specifications, all evolving independently. Some of the features described in these specifications are ready for use today. Others aren't quite ready for use. Others are very, very, very close. In fact, all of these specifications, this family of specifications, is generally what we refer to as HTML5, but there are specifications I don't list here that the committees have just begun working on that I don't even include because no browser supports them yet. But I did want to put this slide together to give you an idea of how I would define HTML5. And I want to start very briefly with this left-hand column, which I headline Ready Now. Geolocation is an API that allows you to build location-aware apps, that allows you to ask the browser, where am I right now? We'll talk about that in detail in just a moment. You'll find that there are various places that location information can come from. But if you wanted to build an app, something like Urban Spoon for the iPhone, which uses the user's current location to recommend nearby restaurants and things like that, you could use the geolocation API to do that. And guess what? It doesn't require a mobile device. It'll even work in a browser on the desktop. Audio and video, something most of you have probably heard of that's supported natively in HTML5. We'll spend a few minutes on that, but I don't want to spend too much time on it because there are other things that are even more important. Canvas API, very, very important API. We're going to go into some detail on it. I'm going to show you several examples. But in short, it allows you to draw into a browser window using JavaScript. Web storage, I mentioned briefly a moment ago. We'll go into more detail on it as well. It's one way in an HTML5 application to store data persistently on the client side, persistently in that it survives browser sessions. So you write the data out in one browser session, the user closes the browser, shuts down the machine, goes on vacation for a week, comes back, powers everything up. They go back and visit that same site again, and the data is still there and available to your app. Now, I list those features as ready now because they're supported by all of today's HTML5 browsers, including IE9, which in terms of HTML5 browsers is the one that's the most problematic because it supports fewer features of HTML5 than any others. By the way, Microsoft has done an awesome job in IE10 of making up for that. In fact, there are some features that only work properly in IE10 right now, even Chrome hasn't caught up to. By the way, I'll be doing most of my demos in IE10, but I'll probably do some in Chrome as well. In fact, there's one or two I'll probably have to do in Chrome because I'll be using features that even IE10 doesn't support just yet. Now, looking at the coming soon column, I labeled it coming soon because those features are there. The specifications, although not formally ratified, are in late stages, meaning that the APIs are likely to change little, if at all. But the reason I labeled it coming soon is those features are supported in virtually all HTML5 browsers today except for IE9. Now, they are supported for the most part in IE10. I'll be going through some of these. IndexedDB gives you a way to do structured storage on the client side. As you'll see with web storage, you're just storing name-value pairs. If you want more structure to the data, not quite a relational structure, but something similar to that, IndexedDB will let you do that. It's not supported in IE9, but it is in IE10. Web workers, very interesting, very important. multi-threaded JavaScript. I'm going to show you some examples of this today. It is for the first time ever possible to write multi-threaded applications in JavaScript. Now, if that scares you just a little bit, hey, wait a minute. What about JavaScript developers who don't have any experience with multi-threading and thread deadlocks and thread synchronization? Well, as you'll see, the web workers model is one that gives us the ability to do work on background threads while at the same time simplifying the model such that there's virtually no need for thread synchronization. Show you some examples here in just a moment. In terms of networking, there's quite a lot that's new in HTML5. WebSockets, for example, allows browsers and web servers to open two-way duplex TCP connections beginning with an HTTP handshake. If you've ever needed to build a web application that runs in a browser but keeps a connection open to the web server so that not only can it send data to the web server anytime it wants, but can get data down anytime the web server chooses to send it down, WebSockets let you do that. If you, for example, wanted to build something like a real-time stock ticker for a browser, rather than continually poll the web server, you could open a WebSocket connection to it if that server supports WebSockets. And now, anytime the server decides new data needs to be shown to the user, it pushes it down to the browser, an event fires there, we catch the event in JavaScript, and we show that fresh data to the user. I'm going to show you something called XML HTTP request level 2 as well as another exciting piece of news in HTML5 networking. And there are other features that we're going to look at: history of navigation, file APIs, HTML5 forms. We're going to look at all of those in the subsequent slides and subsequent demos. Now, on the far right side, I have a column labeled under development. These are features that are coming in HTML5 that few, if any, browsers support yet. For example, increasingly HTML5 is being used as a solution for building cross-platform mobile applications. But if we're going to do cross-platform mobile applications, I'm sorry, I'm just checking a chat message that came in to see that evidently we're having some audio issues. Okay, apologize for that. So one of the things that a mobile application often needs to know is what is the battery status of the device it's running on. Is it running on battery power? If so, what's the battery level? Before turning on a GPS receiver, for example, to get location, you probably want to know that you're either running on AC power or that there is enough battery power that you're not going to drain that battery. Today, there is no battery status API in HTML5, but that is coming in the future. The specification is being worked on now. You can actually go out to the W3C website, find it and read it to see what they're thinking, as are these other features here. HTML5 APIs for accessing contacts and calendars, HTML5 Touch API, something that we sorely need for mobile apps, but that doesn't exist just yet. So, what I want you to take away from this is that the HTML5 feature landscape is large and it is diverse. Some of these features are implemented by all the HTML5 browsers today. Some are implemented by most, but not all of them. And some features are implemented by no or few browsers. But if you look up a year from now, 2 years from now, you'll see features that are currently on the right-hand side moving over to the left as they become implemented by more browser vendors and ready for HTML5 developers to use. It is a constantly changing landscape, one that requires quite a bit of time just to keep up with, to read the latest revisions to the drafts of the specifications and things like that. But the payoff is ultimately, HTML5 browsers are going to give us an amazing platform for building browser-based applications and for cross-platform mobile applications as well. Now, let's take a look at our first feature, the History API. Browsers have always supported browser-specific ways for you to manipulate the history, the browser history, the list of nodes the user has visited. But they've never exposed that in a standard way that works in any browser. They will in the future. In fact, most of them do now, at least the ones that are HTML5 browsers, because of the History API. What this allows us to do, very simply, is access the browser's history so that we can add nodes to that history, we can take them away, we can navigate to nodes in that history. Let me show you a couple of quick examples of how this works API-wise, and then we'll take a look at a real application that uses this. So, in an HTML5 browser that supports the History API, you can use the history property of the window object to access the browser history. Furthermore, you can use the push state property, or rather method, of that history object to add a node to the browser's history. Now, you're adding a node to the history. You're not actually navigating anywhere. You're basically just setting the location that the user is going to go to if they click the browser's back button. So what I'm doing here is passing in the first parameter in a simple object, here using JSON notation, that contains the information I'm going to need if the user does go back to that page to recreate the state of the page, to show the same content that it was showing before, for example. The second parameter is the title parameter. It's currently unused by any browser, but one day you may be able to pass in a title there. And the third parameter is the URI, or the URL, of this node. In other words, where is the browser going to go if the user clicks the back button after you add this node in. Now, the other half of the equation is this. Once you've added nodes to the browser history, if you actually want to know when the user has backed up to them, you register a handler for the new pop state event fired by the window object of your HTML5 browser. Essentially, this event is going to fire each time the user clicks the browser's back button, and your job when this fires is to present content on the page that the user has backed up to that represents what they were looking at before they navigated away from it. Now, that state parameter I passed in the first parameter to push state is available to you here through the state property of the event object that's passed into the pop state event handler. It's a very simple infrastructure, but it allows you to do something very, very important in your browsers. Now, let me demonstrate this for you. And to do that, I'm going to go out and share my desktop. Now, let me give you a word of warning here. I'm running on Windows 8. I found out 2 minutes before the presentation started that there are some issues with Windows 8 and Live Meeting when it comes to desktop sharing. So I hope you can see what I'm seeing here. I'm told that this may prevent us from recording this, but unfortunately I found out a little bit too late to set up a Windows 7 PC to do that. I apologize for it. What I'm going to do is bring up Visual Studio. Let's get ourselves a little bit of real estate here. And I've already loaded the solution that's in the zip file that you can download from the handouts for this meeting. And I want to show you something here. I want to run a simple page. There's nothing HTML5-ish about this particular page, by the way. In fact, I originally wrote this 10 years ago. This page shows some content from a fictitious newspaper called the Contoso Times. And you see a very typical web layout. There's a navigation bar on the left. When the user clicks one of the links in this navigation bar, I'm using jQuery Ajax to go out.
Sorry guys, it looks like Jeff just lost audio. See if we can get Jeff back in. Also quickly apologize to everybody with audio issues in here. We have unfortunately had to take down the 15 meg Visual Studio HTML5 solution in our handout, as it is interfering with the bandwidth from our live meeting servers. We will be posting up a link for you to download that solution. And we're going to try to get Jeff back again.
We've apparently got some visual lag as well somewhere.
Yes, it's bandwidth issues, guys. We do apologize for this. We have nearly 400 people in here consistently, people are downloading the handouts. I've removed the handouts, guys, and we will be posting a link for the handout to be downloaded after this session. We can't get hold of Jeff again. Jeff, can you hear me? Jeff, you seen we lost your audio. You need to unmute or reconnect your audio again, guys.
Bear with us, guys. We appear to have lost Jeff completely. We're trying to re-establish the connection.
Okay, I've just been told that the link for downloading the HTML5 solution is being prepared right now, and we will give it to you guys, and you can get it during this session, not till after. And yes, Jeff definitely completely this time. He's definitely out. We see if we can't get him back. And Jeff is back in again. His audio should be here shortly, we hope. Jeff, are you there, mate?
Yes, I'm here. Can you hear me?
I can indeed. Sorry about that.
Good. No, not your fault. So I had to leave and re-enter the meeting. And the problem seemed to occur because I shared my desktop, which I had been warned can be problematic with Windows 8. So I'm going to try one more time. If I get kicked out again, then what I'm going to do is finish the presentation without sharing a desktop by trying to just verbally walk people through the code. So shall we try sharing one more time?
Yeah, let's try again.
Okay, and by the way, when I shared, were you able to see my desktop?
I could see it, but we were getting people telling us they were seeing absolutely nothing.
Absolutely nothing.
Yes.
Maybe it's a sign that we should not share the desktop. I'm going to try one more time. If this doesn't work, then we'll finish the presentation without sharing, since we know that slide view works here. So let's try it one more time. And Brian, if you lose me, if you would let me know through the chat so I can leave the meeting, come back in, and get things fixed, okay?
Absolutely.
So here we go. Here goes nothing. Okay, hopefully you can still hear me, and hopefully you can see my desktop with Visual Studio as well. Brian, can you just verify that you can hear me and see my desktop?
I hear you clear, loud and clear, and I can see the desktop as well. And then people say maybe they can see the desktop as well.
Maybe it will work. So I want to go back to IE here for just a moment. And you're looking at a page that is not an HTML5 page. It's just ordinary HTML with some fictitious newspaper-style content. And I want you to notice as I click around in the nav bar here, I'm not actually traversing from one page to another. This is all in one page. What I'm doing in response to those clicks is using JavaScript to go out and fetch content from a web service and show it to the user. Now, that's all fine and good, but there's something that's very suboptimal about this, and that is, as I click around, nothing is happening in the browser's address bar. In fact, the back button isn't even lighting up, which means that even though conceptually the user is moving from one page to another, because we've chosen to implement this as a single-page app, there's nothing they can do to back up to the article they were viewing before. This is the kind of problem that the History API in HTML5 was designed to solve. So what we're going to do is run another version of this page, one that takes advantage of the HTML5 History API. It looks the same on the outside, but you'll notice that as I click around here, we do see changes occurring in the browser's address bar. What I'm doing is calling that window.history.pushState to push a node onto the history stack each time the user navigates from one piece of content to another. And now, if the user wants to go back to the article they were viewing previously, they can click the back button, and they can continue doing that until they exhaust the history stack. So one of the reasons this API is so incredibly important is because lots and lots of web applications today use AJAX to fetch content. But making an AJAX call to fetch content and showing it to the user by plugging it into the browser DOM doesn't cause a history node to be added. Now we can have our cake and eat it too, because we can use AJAX to refresh content, to avoid real page transitions, but also to allow the user to feel as if we are navigating from one page to another. Now, with that, let me give you a quick look at the code here, the pertinent code that will interest you if you want to learn more about this API. First, in this page, here is the JavaScript that wires a click event handler to each of those links over in the left nav bar. I'm using jQuery to find those links, then calling jQuery's click method to wire a click handler to each. When one of the links is clicked, I'm first going in and grabbing some information from that link to find out what it is I'm now supposed to display, literally getting the ID of some content, an ID that I'll pass off in a call to a WCF service to fetch that content. Here I'm forming up the service URL, and here I'm making the call via jQuery AJAX out to go load that new content and show it to the user. But here's the really important part from the HTML5 perspective. I'm first checking to make sure the browser I'm running in does support the history API, and if it does, you can see the call to push statement right here. And in that first parameter, the state parameter, I'm passing the ID of the content that I just fetched and displayed to the user. Now that in and of itself would not be sufficient to allow the user to back up to a previous article with the back button. The other half of the equation is this. When this page starts up in the browser, I call add event listener to register a handler for the window object's pop state events. Remember, these are fired when the user clicks that back button. And through the state parameter of the event object that's passed in, I can get whatever I passed into it when I push the state on the stack. In this case, it's an ID. Now I know what ID to use. I go fetch that content from the server, and to the user, it appears as if they backed up to where they were before. It's a very simple API, but one that solves a problem that has bedeviled web developers for a long time. And that's just one of dozens of in HTML5, but it does give you an idea of what HTML5 is designed to do. Now, I'm going to unshare my desktop now on Windows 8. This seems to take a few seconds, so hopefully in a few seconds here we'll pop back. And hopefully I'll find out also that you didn't lose me this time.
No, you're still here, but you've been told that the screen repainting is being a little bit slow right now.
Okay. Interesting. And now sharing is stopped. So, yeah, interesting, these little Windows 8 problems here. I do have one machine in my office that still runs Windows 7, but it's a little bit disconcerting. Anyway, let's get back over to the slides here for a moment. So, let's see here. I'm going to get back to the slides that I was showing. And that is a quick look at the history API. But I want to show you some of the other APIs in HTML5, including the geolocation API, which I find to be one of the most exciting, also useful because it's implemented by all the major HTML5 browsers. What does this API do? As I mentioned before, it allows you to build location-aware applications. I also mentioned before it doesn't require a mobile device. We're going to run it here on my desktop, which doesn't have a cell receiver, doesn't have a GPS receiver, doesn't have anything else, and yet the browser is going to be able to determine with some degree of accuracy where I physically am right now. Now this API is a simple one. I'm going to show you not all of it, but the key parts. Through the navigator object, you can now access in an HTML5 browser a geolocation object, which exposes to you a method named getCurrentPosition. That's an asynchronous method. When you call it, it returns immediately. Therefore, you provide to it in its first parameter a callback function. Once the browser has determined that it thinks it knows where you are, it will call that callback function. And you can see from the slide here the kinds of information that the browser provides to you, including a latitude and a longitude. Now, There are several places this information can come from. If this is running on a mobile device with a GPS receiver and GPS is enabled, the data could come from GPS and it could be very accurate to within a few meters. On the other hand, if you're running on a device that doesn't have a GPS receiver, like a desktop, and you don't even have a cellular connection through which cell tower triangulation could be used to approximate your location, then the browser will attempt to use something called Wi-Fi positioning. That is, if you have a network connection, it will attempt to translate your IP address into a physical location on the face of the earth. Now, there's some black magic involved in that. I won't go into detail, but there are several large companies like Microsoft and Google that maintain Wi-Fi positioning databases, and their browsers rely on services that front end those databases. There are a lot of tricks that they pull to make the information as accurate as they possibly can, but believe it or not, it works and often works with an uncanny degree of accuracy. By the way, there's no API here that lets you know where the data is coming from, but you can infer it. If, for example, you get a latitude and a longitude but no altitude, that tells you the data is not coming from GPS, because only GPS can give you an altitude. By the way, if it gives you an altitude, that value is expressed in meters. Neither Wi-Fi positioning nor cell tower triangulation can give an altitude. You can also look at that accuracy property to infer something about where the data is coming from. If it's a very low number, like 3 to 5 meters, the data is almost certainly coming from GPS. Typically, if the data is coming from cell towers, then it'll be on the order of 100 to 300 meters. If it's coming from Wi-Fi positioning, it could vary from a few meters up to thousands of meters. Now, you also see a couple of properties named heading and speed. When you call get current position, you won't actually get values there. There will be null or not a number. But there's a companion method named watch position that you would use to build real-time navigational apps that actually will start passing real values there. Heading being a value from 0 to 360, representing points on a compass, and speed being a speed in meters per second, that tells you once the user has begun moving, which direction they're moving and how quickly they're moving in that direction. Now, when you call get current position, you're never guaranteed that data will come back, even if the machine that this is running on has a Wi-Fi connection. So here's what you need to do. When you call get current position, you need to pass in a second callback function. We call this the error callback. If the browser cannot or will not divulge the user's location, then the error function will be called rather than the first function, the success function. And there are three possible reasons that that error function can be called. One, a browser will never divulge a user's location without permission from the user. If the user is prompted to by the browser to divulge their location, they say no, your error function will be called with a value of permission denied. On the other hand, if the browser is simply unable to determine your location, then it will send you position unavailable. Now, the third error value there, timeout, let me say a little bit more about that. By default, you'll never get that timeout, but when you call get current position, it could take a few seconds or more for the browser to figure out where you are, especially if it's having to get a lock on 3 GPS satellites. There is a third parameter you can pass to get current position that allows you to specify position options, which I list right here. Let me show you one example of that. By default, most browsers on mobile devices will not use GPS unless specifically instructed to. Why? Because GPS receivers tend to be very consumptive of battery power. When you call get current position, if you would like GPS data to come back to you if it's available, you must tell the browser that by specifying enable high accuracy equals true in a position options object in the third parameter, as you see right here. Now, I haven't shown it, but you can also specify a timeout value there in milliseconds. You can say to the browser when you call get current position, I'll give you 10 seconds to get back to me. If after 10 seconds you still don't have the information, then the call should time out. And in that case, your error function will be called, and you'll be told that the reason for the error was a timeout. Now, sharing worked last time, so I'm going to cross my fingers and we're going to try it one more time. Let's go back here and share the desktop. I want to show you an application that uses this API and show you a little bit about how it works. So hopefully you can still hear me, and hopefully you can see Visual Studio.
Yes, loud and clear, and I can see you now.
Excellent. Hey, maybe I didn't cross my fingers right the first time, huh? So,
Could be.
I still have open the solution that is in the handouts for this session. Again, you're free to download that, use the code any way you want to. But I'm going to go to a different example. I'm going to go into the location folder and run something called maplocation.html, which not only uses the location API to get my current location, but combines that with the Bing map to show pictorially where I am. So let's fire up IE and let's see what happens. Notice at the bottom of the IE window, a message says localhost wants to track your physical location. Again, a browser will never divulge your location without your permission. I'll say allow once because I want to be prompted again the next time. So in a moment, we'll see the Bing map change to show where it thinks I am. Now, let me tell you this. I live out in the country in East Tennessee. My ISP is about 30 miles away down some country roads. And what you're actually seeing here is the location of my ISP's office. When you're in more populated areas like Redmond, Washington, or the Silicon Valley, you'll find that this data, which is coming from Wi-Fi positioning, can often be uncannily accurate. It'll not only get the building you're in, but the room that you're in that building. And that's thanks to some really clever stuff that companies like Google and Microsoft and others that maintain Wi-Fi positioning services do. But if I were to look at the accuracy value here, the accuracy parameter, it would tell me that it's not very confident about the data. So let me show you real quickly the key code in this, and it makes it pretty simple. First off, when this page starts up, right here you see me calling get current position. I've specified both the success function and an error function. And in the success function here, I take the latitude and longitude passed back to me by the browser, and I stuff it into a Microsoft.maps.location object. That's a JavaScript object that exists because of this script element up here, the one that includes Bing Maps. This is basically downloading a bunch of JavaScript to my browser that implements the Bing Maps API. I then, let's see, I've already created the Bing map. You can see that happening here. I call set view on the map and tell it to center itself up on the latitude and longitude just given to me by this call to the location API. So really simple stuff. It shows that it can be incredibly easy to build a location-aware app. One other thing I'd like to mention, before you call Bing Maps APIs or use a Bing Maps control, you have to go to the Bing Maps website and sign up with your email address. They send you a set of credentials, an API key, that you have to submit in every call up to Bing Maps services. This is my API key right here. I left it in the sample code because I figure the world's not going to end if you use it, although if you use this in a real app, it could get me shut down, at least in theory. So I would encourage you not to use my API key. If you're going to build a location-aware app that uses Bing Maps, please go register. It's free. Once you register, you generally have your key within a couple of minutes. But again, I wanted to include this one here because I wanted you to be able to run this app without having to go off and register and do all that. So we will pop back over to the slides here. Again, in Windows 8, it seems that when I tell it to stop showing the desktop, it takes 20 or 30 seconds or so to do that. And yes, Brian, I'll see if I can drop my resolution down a tad. And it looks like, nope, we don't want to shut down live meetings. We're just waiting for it to respond here. It would be interesting to know why Windows 8 and live meeting don't play very well together. But looks like we're back. And hopefully you can still hear me. Let's go back to the slides. Got lots of stuff to cover, so I want to try to cover this as efficiently and as quickly as possible. Another big feature of HTML5 that gets developers excited is the Canvas API, which, as I've said already, allows you to draw directly into the browser window from JavaScript. I can easily spend 2 or 3 hours on Canvas. In fact, I do that in the class that I teach. I'm going to give you just enough of it to give you some ideas of what it can do and how you get it to do that. So let's take a look here at a couple of examples. By the way, all of my slides that introduce a feature of HTML5 have this little graphic at the bottom that shows you which browsers implement this feature. Here you can see very plainly, for example, that IE 9 and higher supports this. So does Chrome 4 and higher. It's not easy to get that information. I spent quite a bit of time compiling it, testing it in different browsers, so I hope that those little graphics will help you, because you can look at a feature and before you decide whether to use it, you can say, wait a minute, is it going to be supported in the browsers that we target with this application? So, quick look at the Canvas API. Let's say I want to draw into a browser window from JavaScript. I began by declaring one or more canvases in my HTML5 document. Then, in JavaScript, I get a reference to that canvas, and I call a method on it named getContext. That returns an object of type canvas rendering context 2D, which actually contains the API, the methods and the properties that allow me to draw things. Here, I'm calling canvas rendering context 2D stroke rect method to draw a rectangle that's 200 pixels wide and 100 pixels tall, whose upper left corner is 100 pixels to the right of and 50 pixels down from the upper left corner of the canvas. Yes, you can change the origin of the canvas. There's actually quite rich support for translate transforms, scale transforms, and rotate transforms here. But in terms of units, the only units that are supported are units of pixels. Now, suppose I wanted to draw a filled rectangle rather than just a rectangle outline. To do that, instead of calling stroke rect on the rendering context, I would call fill rect, as you see here. Now, maybe I need to draw something that's not just a black rectangle. Maybe it needs to be blue or red. The canvas rendering context 2D object not only has a whole bunch of methods you can call to produce output, it also has a bunch of properties that control the visual attributes of that output. One of those properties is one named fill style. By setting it to red or any other valid CSS color identifier, that means when I call a method that fills something, I want it filled with red. You can also fill with images, with gradients, both linear and radial, and other things as well. There's quite a lot of richness here. Now, in addition to giving you methods for drawing rectangles, there are also methods for drawing paths. And a path in Canvas speak is just a geometric or mathematical representation of a two-dimensional polygon. It can be simple or it can be complex. Here's how you would draw a circle using the HTML5 Canvas API. There is no draw circle or draw ellipse method, but you can define a path that is a 360-degree circle, which is exactly what I'm doing here. Then you can call fill to fill that path, and in this example, you'll get the red circle that you see on the slide. Of course, you're not limited to arcs. You can use lines and splines also as the boundaries for the edge definitions on these paths. In this example here, I create a new path and I'm calling move to and line to position an imaginary pen and draw to different points forming a triangle. Then, when I call stroke to apply ink to that path, I get the rectangle that or the triangle that you see. Had I called fill, by the way, instead of seeing a triangle outline, you would have seen a filled triangle. So those are the bare bones basics of Canvas, but you can do a lot more than those simple slides would imply. What I'm going to do, I'm going to shoot my resolution down some here to see if the video will go out a little bit better. And then I'm going to share the desktop again. Okay, and yes, we want to keep those changes. Okay, let's try sharing again and see if the response is a little bit better here. So, go back out to the desktop. Got my fingers crossed again. Hopefully I'm staying around. Okay. So, let's close down this document and let's go into my Canvas folder where I have several examples of the kinds of things you can do with Canvas. Starting with a page named chart.html, where I use methods like fillRect and move to and line to draw rectangles and lines, and to draw this chart that you see right here. Now I'm just using hard-coded data on the client side to draw the chart, but You could, of course, be using Ajax to make a call out to a service somewhere, getting data back, and then rendering that data from the source rather than hard-coded on the client. But there are a couple things to take away here. I won't go through all the code, but I'm using that fill rect method you saw to draw the bars in the rectangle. There are also methods in the rendering context for drawing text, for rotating things you draw. You can see the rotated text along the y-axis here. There are even methods you can call and properties you can set to produce shadows. Here, just to give my chart a little bit of verve, I asked the canvas when I drew out the text annual widget production in the top to produce a drop shadow behind it. So I'll leave it to you to go through the source code, but there's not a lot of code there, maybe 40 or 50 lines of JavaScript producing a simple chart. Obviously, you could produce an infinite number of other things as well. Let me show you something else that's kind of interesting about Canvas here. Right here. And once more, in the interest of time, I'm not going to take the time to walk through the source code, but I wanted you to be aware of this, so if it's something that interests you, you can look at the code on your own time. So what I'm doing here is actually layering canvases on top of each other. It's a fairly common technique used with the canvas. The reason I'm doing the layering is I want these spotlights that you see, which I'm drawing using the Canvas API and I'm animating using a timer, to move back and forth, and I want them to appear in front of that background, the mountainous background you see, but I want those spotlights to be clipped out by the buildings in the foreground. So there are two canvases here. Actually, I take that back. There's one canvas, but I've used CSS3 absolute positioning to position the canvas in between, in the Z order, two images. Then when I draw on the canvas, it's the browser that's doing the clipping for me up front. The browser can do it much more efficiently than I could in JavaScript. So if something like this looks interesting to you, or if you've heard about layering canvases to get automatic clipping, this is a great example to look at. Let me show you another example that you may find kind of interesting. In this one, puzzleanimation.html, I'm taking an image and I'm programmatically cutting it up using the Canvas API into lots of little squares. Then the user can click one of the squares adjacent to the empty square, and I move the piece of the puzzle. So you can click around, and you can scramble that thing up, and then you can try to get it unscrambled if you want to. I'm using jQuery animations, by the way, to slide the puzzle pieces. That really has nothing to do with HTML5, but the HTML5 part of it is kind of interesting. Let me open that page up real quick. And point you to this code right here. What I'm doing is first creating an image object in JavaScript. Then I'm setting its source property to load that landscape image that you just saw. But that is one monolithic image, and I want to carve it into little pieces, representing pieces of the puzzle that I can move independently. So take a look at the DOM in this page. I've got 11 canvases declared. So here's an example of an app that uses not just one canvas, but several. Each canvas here is one puzzle piece. It measures 150 by 150 pixels square. In the code up here, I'm using the Canvas API to cut up the image, to basically take squares from the image and to draw them onto the different canvases. Now, because the canvases are different DOM elements, it's simple enough to use jQuery to move the pieces around when the user clicks one of them. So, great example here of how you take images and cut them up using the Canvas API. And I've got some other examples here too you may find interesting. This one I call Scribble. You see a chalkboard image when it starts up, and what I'm doing is letting the user draw with the left mouse button, as you see right here. Now, this type of application is a great example of the Canvas API at work because I'm literally drawing lines onto this canvas, connecting coordinates that the mouse has traversed as mouse move events fire. Very easy to do this kind of thing with HTML5 Canvas. Without it, you would need a browser plugin, SVG, or something. One last thing I want to show you is this one right here. It's called Mandelbrot.html. One of my favorite aspects of the HTML5 Canvas is you're not limited to just drawing lines and shapes and things like that. You can generate images from scratch. And this is one example of an app that does that. Now, we're going to launch it here, and unfortunately, you're going to see an IE10 It's not going to be very performant. What I'm doing right now is in JavaScript generating about a million pixels representing the Mandelbrot fractal. And the algorithm I'm using is very CPU intensive. For each pixel, I'm going through a loop up to 128 times. As you saw, it took IE several seconds to render that image. It's actually better in IE 10 than it was in 9. But what I'm going to do is paste that URL into Chrome, which is actually much, much faster at this. And what you'll find you have now is an interactive view of the Mandelbrot set. Where if I click right here, we zoom in to that location. Let's click here. That looks kind of interesting. Maybe I want to go even further. I'll click right there. The wonderful thing about fractals, of course, is that they have infinite complexity. Here, you can keep drilling down until you get bored. Now, the reason I included this sample is the entire UI for this app is nothing but an image. And the image is being generated from scratch, pixel by pixel, when the app starts up and each time a click occurs. This is the type of application that would have been difficult to do without Canvas, but because Canvas does give us pixel level control over over what we show, we can build apps like this. I won't go through all the code, but if it's something that interests you, mandelbrot.html is the name of the page. By the way, the reason Chrome is so much faster, the short story on that, it turns out that JavaScript, for the most part, is no longer an interpreted language. All modern browsers JIT compile it, sort of the way a lot of us compile C# into IL, and then the CLR JIT compiles that IL into native code. The problem, though, is that JavaScript is a typeless language. So when a browser vendor writes a jitter for JavaScript, they end up making some assumptions. It turns out that the code that I'm running here is very floating point heavy, and Chrome happens to optimize its jitter for floating point math. IE, on the other hand, optimizes for integer math. So I could just as easily build a benchmark that makes IE look 10 times faster than Chrome, but when you're dealing with heavy floating point math, as I'm doing here, you will generally find that Chrome is faster than IE at doing that. Okay, let's unshare now. Go back to the slides. Now that I've shot the resolution down a bit, maybe we'll find that it goes back a little bit faster. In fact, it does. Maybe if I run it, excuse me, 640 by 480, we'll overcome the problems altogether. How about it? Now, that's a quick look at the Canvas API. Again, there's several examples in the zip file that you can download from the handouts. But let me follow all that up by mentioning another feature of HTML5 called web workers. Now, these are fairly late to the game, but also incredibly enticing. Historically, JavaScript developers have not been able to write multi-threaded code. Now they can. Web worker is a euphemism for a background thread in HTML5. Now, as I mentioned earlier, the problem with multi-threaded code, concurrent code, is that it can be very complex. If you've written multi-threaded code before, you know it's next to impossible to make sure that threads are synchronized so they're not colliding over the same piece of code. What they've done here is give us a model that kind of gives us the best of both worlds. The ability to do work on a background thread without having to worry about synchronization. And the way they've done that is essentially this. When you want to execute some work on a background thread in an HTML5 browser, you simply do up a worker object, and you pass it the URL of the JavaScript file containing the code that you want to run on that background thread. In this very simple example here, I want to add 2 and 2 on a background thread, so I put this line of JavaScript you see at the bottom in a JS file and reference it in a worker constructor, as you see here. Now, under the hood, by the way, what the browser is doing is using the host operating system's thread pooling API. In Windows, it's calling threadpool.queue user work item, for example. Actually, it's queue user work item in Win32. So you never guarantee it's going to run. You never guarantee that in Windows anyway. But you are, when the code executes, it is executing on a background thread. Now, that's a trivial example, but you can imagine if you were doing some heavy number crunching, you do that on a UI thread, you're liable to freeze the browser up and make it less responsive. Do that number crunching on the background thread, however, and the UI thread is free to continue pumping messages, so you can do that heavy computational work without impacting the responsiveness of the application. Now, let me show you a little bit more here. I've mentioned earlier that they have vastly simplified the multi-threading model to prevent you from having to become an expert on thread synchronization. Guess what? When code runs on a background thread or web worker in this parlance, there is no window object and no document object available to that background thread. It runs in a very special context that's different from anything you've seen before in JavaScript. There is no need for synchronization primitives in HTML5 web workers because there is no way for two threads to access the same piece of data. That does mean, however, if you're doing a computation on that background thread and you want to display the results to the user, well, since you don't have access to a document object or a window object, you have no way of showing that data to the user. What you can do, however, is call a post message to post data back to the UI thread. The UI thread can then display the results of the computation to the user. That's what I'm doing here. Once I've added 2 and 2, I'm posting a message back to my owner, the UI thread. Which means, of course, the UI thread is going to have to know how to respond to that message. So after newing up the worker in the UI thread, I register a handler for message events fired by that worker. Each time the web worker now calls post message to post a message to me, the message event will fire on the UI thread, and through the data property of the event object passed in, I can access whatever data was passed to the post message method in the background thread. It's also possible to communicate the other way, for the UI thread to post messages to a worker containing data. Maybe you want to start that worker up, but you don't really want to let it loose and have it start doing the computations until after you've got some user input. Here I'm calling post message on the worker object I created. That's going to cause a message event to fire down inside the worker, and it too can register a handler for message events, and it can receive those messages. In fact, this is exactly how it does that. In the JS file containing the script the worker runs, notice I call add event listener to register a handler for message events and designate this on message method as the one that will be called. So what do we have here? We have a way of putting work onto background threads by encapsulating that work in logic in a separate JS file. We have mechanisms for posting messages to a worker and from a worker, two-way communications. But in no case can a worker actually access the UI, the window, the document, or anything else itself. And again, the reason for that is to give you the power of multi-threading without requiring you to become an expert in thread synchronization. By the way, one reason this is important, on desktop devices these days, almost all of us are running multi-core machines. So to really leverage multiple cores, you've got to be able to do multi-threading. Without this, HTML5 apps would not be able to leverage multi-core machines. Now they can. Let's go back to my desktop for just a moment, and let me show you an example of workers in action. So back in Visual Studio, I want to go into my workers folder, and I want to run something called multi-mandelbrot.html. This is a multi-threaded version of that Mandelbrot app you saw a moment ago. And once more, just for good performance, I'm going to run this thing in Chrome. So let's pop up Chrome here and ask it to run multi-mandelbrot.html. And here's what I'm doing this time. I'm actually running on a 4-core machine right now. And it struck me that on a 4-core machine, all this computational work being done to generate pixels, hey, could be split up among the cores if only I had a way of doing the work on multiple threads. So what I'm doing in this app is very simple. I carved the browser window into quadrants. I create 4 workers, and I let each worker do the computations for all the pixels in its quadrant. When each worker completes its computation, since it cannot access the UI directly, it posts a message back to the UI thread with all the pixels whose values it computed. And the UI thread then uses the Canvas API to display those pixels to the user. Now, if I click around here, you may not be able to see this through live meeting, but live I can actually see the quadrant painting or the screen painting one quadrant at a time. But because these threads are able to run concurrently on the different cores, conceptually at least, I'm not only building a more responsive application here, I'm also building a more performant application. Now, just real quickly, looking at the code, let me show you a couple of the highlights here. This is one of my favorite examples. Looking right here, you see me creating 4 image data objects. Those are part of the Canvas API. They're basically the HTML5 Canvas representation of the bitmap. I'm creating 4 empty bitmaps, one for each quadrant of the screen, so that ultimately I can paint pixels from those bitmaps onto the screen itself. Then I create 4 workers, and I pass in UI of the script named mandelbrot.js. That's where the code is that does the pixel computations. And then I register a handler for message events fired by each of the 4 workers so that my UI thread will now know when each of the workers posts a message back to me. Then I post a message to each of the workers, passing in some information that tells it, among other things, which quadrant of the display it's responsible for. And then I don't do anything else. On the UI thread, I just wait for those message events to fire. And when they do fire, and this event handling function is called, here's the magic call that uses the Canvas API to take all the pixels computed by that background thread and display them to the user here on the UI thread. There aren't a lot of good examples out there of multi-threading at work. There are lots of trivial examples, but for something that's more real world, more practical, this is one of the few examples I know of. That's why I decided to include it in this demo set right here. So with that, let's go back and tackle the next feature. Okay, I see we have about 20 minutes left. I want to get through as many features as I can here. Next one, I believe, is web storage. Is that correct? Yes. And I'm going to do this one quickly because it's pretty simple stuff, but also important. Historically, when browser-based apps have wanted to store per-user data, like a language preference or a username or something, they store the data in a cookie. And there are lots of things that are not quite right about that. That cookie travels back up to the web server in every request. It's exposed to anyone that has access to what's going over the wire. It's also limited typically to about 4K of data. If we're going to use HTML5 as an app platform, we have to provide a way for applications to store data, larger amounts of data, on the client side. And one way to do that in HTML5 is web storage. Now, there are 2 basic types of web storage. There is local storage and session storage. Local storage is persistent. It survives browser sessions. Session storage does not. When most developers talk about web storage, they're actually talking about local storage because what they really want is to be able to store the data persistently. So let me show you how it works here really quickly. Basically, local storage is accessed through the local storage property of the window object. It is essentially a dictionary of values, which can be anything you want, but they're keyed by strings. So let's say I support localization in my app, and the very first time a user visits my site, I ask them which language they prefer to see content in. But I want to save that preference so that next time they come back, I don't have to prompt them again. So here I'm writing the string ENUS into local storage, keying it with the key or the string language. Then later on, maybe when the app starts up again or what have you, I reach into local storage, find out if that value is there, and if it is, I pull it out. So think of it as cookies, but nothing's traveling over the wire. You're no longer limited to 4K of data. You could store much larger objects here if you wanted to. Now, one thing you do need to be aware of is that while you can write virtually any type into local storage, browsers do stringify the data before storing it, which means that if you write in a JavaScript number, the number 16 as I'm doing here, when you read it out, it's going to come out as the string 16, and it is your job to convert it back into its original data type. This is not something the browser will do for you. It's something that you will have to do yourself. One thing that you need to know about if you're going to use web storage is quotas. If an HTML5 app could write an unlimited amount of data to local storage, since ultimately it's being stored on the hard disk and stored in different places by different browsers, by the way, then a malicious app could fill up that user's hard disk. Therefore, all browsers today limit how much data can be written to local storage. The HTML5 spec suggests a 5 megabyte quota. It literally uses the word suggest, and most browser vendors actually adhere to that today. One thing you need to be aware of is that that is a shared quota. For example, let's say you work at www.wintellect.com like I do, and there are 10 different apps published in that domain. If all of them write to local storage, it's not that each of them can write 5 megabytes, it's that the sum total of what all 10 of them can write is 5 megabytes because they share an origin, www.wintellect.com. That's a bit unfortunate. Yes, it can be problematic, but the alternative is to open the door to malicious applications. If you're familiar with isolated storage and Silverlight, you know that they impose similar quotas over there. By the way, there is not an API, at least not a standard one in HTML5 for finding out how much quota you have remaining. Some browsers provide browser-specific APIs, but there is no HTML5 API for finding out if you have quota remaining. That means that anytime you write to local storage, even if you're writing just 1 byte, it could throw an exception because your quota may already be full. That's why when you write to local storage, you always want to code defensively, as I'm doing right here. Anticipate that an exception may occur, and then if you find that it occurred because your quota was exceeded, at least hopefully you can respond to that gracefully. By the way, you can call clear on local storage to delete everything. But be aware when you do that, it's not only going to delete everything your app has written there, but any other app that shares the same origin that you do, yours does as well. So in the interest of time here, I'm not going to show you this demo. I will point you to it. In my storage folder in the samples, there's a page named scribble.html. It's another version of that Scribble app I showed you earlier, the one where I used the Canvas API to scribble on the chalkboard. But this time, as you scribble, it's actually writing the coordinate pairs, defining the scribbles into local storage. That means you can shut down the browser, turn off your machine, come back later, start the app again, and when it starts up, the app reads from local storage all the XY coordinate pairs that were there and recreates what you had drawn. So you can see a wonderful example there of local storage in action. Now, let's talk about files. HTML apps, JavaScript apps in general, have never had a standard way to do file I/O. And for good reasons, because there's a lot of security concerns surrounding that. There's actually a specification that's part of the HTML5 family called the File API that gives you a way to read files from the hard disk, not write to them, but read from them. Now, there are 2 other file-related HTML5 specs. One is called the File System API, the other is the File Writer API. It's only partially right now, so they're not quite ready for prime time, but ultimately we will be able to write the files on the hard disk as well as read them. But if you want to read from files on the hard disk, you can do it using this API. By the way, never in an HTML5 app can you go out and hit that file system without the user's permission. The user has to be involved. They either have to choose a file or set of files through an open file dialog before you can, before you're allowed to open them in your app, or the user has to offer you those files through drag and drop, one of the 2. Again, you can never just go out, open a file, enumerate files in a directory or anything like that without the user knowing about it. So suppose you wanted to build an app that lets the user open a file. Maybe you're going to build a browser-based Word document viewer or PDF viewer. You begin by declaring an input type equals file element, which allows the user to choose the file through an open file dialog. Then you register a handler for the change event that will fire when the user makes the selection. And in that event handler, here's the key. Through e.target.files0, I get a JavaScript file object representing the file that the user selected. By the way, HTML5 browsers do support multiple file selections by including the keyword multiple in the input field here. I'm telling the browser the user can select multiple files in the ensuing open file dialog. And the reason that this files property is an array type property is if the user chooses 10 files, there will be 10 file objects in that files property. Now, Once you have a file object representing a file, what can you do with it? One thing you can do is get some information about it. You can get its name, its type, its size, and its last modified date. This is all the information the browser exposes to you. You cannot, for example, find out what the path to the file was because of the security implications that would involve. But you can get basic information about the file, as I show here. But more importantly, you can also open the file and read its contents. You do that by using methods of the file reader object, which is defined in the file API specification. There are 4 methods in that object that will interest you, which I've listed right here. Let me show you a couple of examples. Suppose you wanted to open and read a text file. You new up a file reader object and you call read as text on it, passing in a reference to a file object that you received when the user selected that file. Now, read as text is an asynchronous method. It returns immediately. Before you call it, you register a handler for the onload event that the file reader will fire once it has finished reading the file's contents. And in this case, because it was read as text that I called, e.target.result will contain a string that represents the contents of that file. But there are other methods for reading other types of files, for doing binary reads, for example, or something that I found useful, and I'll be showing you in the next example, reading an image file, a JPEG or PNG, and displaying the image bits to the user. Notice instead of calling read as text on the file reader object, I'm calling read as data URL. Data URLs, you may have seen them before, instead of pointing to something, they actually contain the data. They can be many, many megabytes long for an image file because all the image data is embedded right there in the URL. This time, when the onload event fires, e.target.result contains not the contents of the file per se, but a big long string that is the data URL, which I can assign to an HTML image in order to show that image file to the user. Now, let me show you an example of that real quickly. I'm going to share out my desktop one more time. And I want to go into my, let's see, which folder am I looking for? The Files folder, and show you a little app named photofinish.html, which is kind of a fun one. I think you'll agree. What it allows me to do is through this input type equals file element, select a file from my hard disk. And the file I selected is a picture of my daughter that was taken several years ago. And I chose this picture because you can see those terrible red eyes. Now, her eyes don't really look like that in real life. They're actually very pretty and sort of a hazel color. But suppose I wanted to fix those red eyes. What I'm going to do is click each of the red eyes. And when I do, the red eyes get fixed. Now, I'm using the Canvas API to edit those pixels, to run a red eye reduction algorithm on those reddish pixels. But that's not the big point behind showing this demo. The big point is I'm also using the File API to read that JPEG file from the hard disk and show it to the user so that they can see the red eyes that they want to fix. And just real quickly, let me show you here where the pertinent code is for the File API. Here is the JavaScript function that is the event handler for the change event by when the user selects an image file from that open file dialog. I'm getting a reference to the file object itself. I'm making sure it's an image file. Obviously, it doesn't make sense to try to fix red eyes in any other kind of file. Then I new up a file reader object and ultimately call read as data URL on it. That means that once the reading has been done and the data URL has been constructed, the onload event will fire, and this is where I'm actually showing it to the user. And I'm not just showing them the image. I'm drawing the image onto a canvas so that I can then edit the pixels in that image. So a really good example to look at if you want to dig deeper into an application that uses both the File API and the Canvas API as well. Now, we still have a little more than 5 minutes. With your permission, I'd like to cover some more stuff. Let's see here. Let's go right back to the slide. WebSockets. We'll just close out the day with a look at WebSockets. WebSockets are one of several important new features of HTML5 in the networking arena. I briefly described these earlier. Remember, they are a solution for applications that need to keep open a real-time connection between them and the web server so that the web server can asynchronously push data down at any time they want to. Think about real-time stock tickers, sports scores, nuclear reactor core temperatures, or anything else where latency is a bad thing. Now, WebSockets have gotten so much buzz and so much support. They're supported in other places outside of HTML5. For example, there's some very good WebSocket client support built into Windows 8. There's also very good support for building WebSocket servers in .NET 4.5. In fact, I'm going to be leveraging that server-side support in the next example that I show you. But just real quickly, this API is very simple. If you want to open a WebSocket connection to a server that's supportive of that, you new up a WebSocket object and pass in the URL, the endpoint that the server responds to. Notice the protocol here, WS for WebSocket, not HTTP. By the way, some servers that support WebSockets do support secure WebSockets, kind of like HTTPS. For those, you use the protocol prefix WSS for WebSocket secure. Once you have WebSocket open, you can call its send method to transmit data. In the early days of the WebSocket spec, you could only transmit strings, but they've since modified that so that you can send string data or binary data. And I'm showing very quickly here some examples of how you do send both string and binary data. But remember, the really, really important thing about WebSockets isn't just that the browser or client can push data up to the server anytime it wants. It's that it can receive data back anytime the server decides to shoot it down without polling or anything like that. Behind the scenes, there is a duplex to TCP connection being held open. By the way, WebSockets tend to be friendly to firewalls because the connection is negotiated over HTTP, typically over port 80, although that's not a requirement, and then the TCP connection that's open uses the same port. So if port 80 is open in the firewall for that web server, which it almost certainly will be, that web server can probably serve up WebSocket connections without any configuration changes. When data is pushed from a WebSocket server to a WebSocket client, in an HTML5 client, a message event fires. If I want to respond to those messages, I simply register a handler for those events as you see here, and the data, whatever it may be, it can be text or binary that the WebSocket server pushed down, is then accessible through the data property of the event argument passed into the message event handler. Okay, we're going to close out the day with another demo here. And this is what I just recently put the finishing touches on. We have to hope that it works. I'm going to go into my networking folder. I've got something called WebSocket Scribble. We're going to fire it up here in IE10. Okay. And let's shrink that down just a little bit to get some real estate for ourselves. And then I'm going to open another instance of IE10 and paste in that same URL. And once more, let's resize that so that we have we can see both instances of IE side by side. Now, what's happening here is this is a sketching or scribbling application, kind of like the one you saw before. But this time, each time my finger comes off the mouse button at the conclusion of a stroke, the client in which I did the drawing sends the data defining that stroke up to a WebSocket server. Both of these clients attempt to connect to that WebSocket server when they start up. And when the WebSocket server receives a call from a client indicating something has been drawn, it broadcasts that out to the other client. So if this works, when I draw in one of these windows, what I draw appears in the other. And it goes the other way, by the way. I can draw in this one, and you can clearly see that thanks to the WebSocket connection that both of these clients have to a WebSocket server, they're aware of what each other is doing. Now, real quickly, the code that makes this work is relatively simple. You can see right here, for example, when each client starts up, it is newing up the WebSocket object, passing in this local address of a service here. And then each time I finish drawing a line, and let's see where that code is. Get towards. Is it on mouse up? Yes. I call a local helper method named transmit points, which uses that WebSocket connection to transmit all the points that finding the stroke that was just drawn up to the server. At the same time, each client registers a handler for those message events so that if the drawing is done in another client, and that's communicated to this one through the WebSocket server, here it duplicates all the lines making up the stroke that was just drawn. And one final thing, if this interests you, if you want to know how to write a WebSocket server using .NET 4.5, look in my services folder and look for Scribble WebSocket Handler.ashx. This project, by the way, this Visual Studio solution, has to run against .NET 4.5 because this stuff right here is new in .NET 4.5, but this is how you write a WebSocket server. The key is that you write an HTTP handler in its process request method, which you may have seen in ASP.NET before. You can check to see if this is a request for a WebSocket rather than an ordinary HTTP request. Then you call the new HTTP context method named accept WebSocket requests, and then write event handlers. There are lots of frameworks that let you write WebSocket servers. Few, if any, make it as easy as .NET 4.5 does. My clock says we are just about out of time here, so I hope to reserve a little time for questions and answers. However, I want to get through as much content as I possibly could. So let's do this. We will call the presentation to a close. If you have any follow-up questions, you can contact me at jeffpro@wintellect.com. That's JEFFPRO @wintellect.com. Or you can communicate with Brian or anyone else that you received information from for this event, and I'm sure that he'd be happy to forward that to me. Wow, I apologize for the technical glitches we had up front. I think that once I followed Brian's suggestion and shot the resolution down, I think it got a little bit better. I certainly hope so. Brian, are you still there?
I am indeed. Yes, thank you very much, Jeff, for going through this here. We definitely had some technical issues today, and the audio on my side was actually quite good all the way through, but obviously other people were having quite a lot of issues. We do apologize for the technical issues, guys, and we will try to find another solution than a live meeting, because it's honestly, it can't handle the numbers we are getting in here, and it's very hard to troubleshoot some of the problems we were having. I do know that we have a winner for the, where did my country go? We do have a winner for the virtual training course, valued at $499. And the winner is Mr. Jerry Carlin. Jerry, thank you very much for attending and for sticking through today's presentation, even with the issues we had. Jerry registered. He's been a LIDNUG member since 2010. And obviously he's been attending today. So congratulations, Jerry, and I hope you get to enjoy it. Okay, thank you very much, Jeff. Again, also want to thank you, as I said, for being patient. We did have indeed these technical issues, but you got through it pretty well. As I said, putting your resolution down resolved quite a lot of the audio issues we were having. Again, last thing, thanks for everybody. Just want to mention the demo code that Jeff had provided, that we had to take down in the handouts, is now available. And let me quickly put it up here. You can find the download at www.wintellect.com/downloads/HTML5 webinar. You should see the link now on screen. Okay, I think that's it. If anybody has questions, I don't know if there's any questions in there. Actually, there is one. Jeff, there's a question here. One is asking about your Visual Studio setup. Is that a vanilla installation of Visual Studio, or have you installed something else? Maybe we lost Jeff again when he stopped sharing his desktop like he did last time. So will we go? Looks like we might have dropped Jeff again. Okay, that's it. Thank you guys. Any questions, feel free to email any feedback to us to info@lidnug.org.